Next, we want to review absolute value here. So remember that the absolute value of a number a is a if the value is greater than 0, and it's minus a if the value is less than 0. So for example, the absolute value of -2 is positive 2. So if it's less than 0, you got to change the sign. But the absolute value of 3 is equal to 3. And geometrically, remember, this represents distance of those values from 0. So you've got 0 in the middle. -2 right there is 2 units from 0. And positive 3 is 3 units from 0. So now we're going to use something called the Triangle Inequality, which says the absolute value of the sum of two numbers a and b is actually less than or equal to the sum of the two absolute values. So if you break it up, then it could stay the same or get larger, but it can't get smaller. So let's put this to work. If absolute value x plus 1 is less than 0.03, for some value x, and absolute value y minus 5 is less than 0.08, then we want to estimate the quantity absolute x plus y minus 4. Well, what we want to do is use the triangle inequality. This is our a, x plus 1, and this is our b, y minus 5, and then this is our a plus b. So notice that the absolute value of x plus y minus 4 is equal to the absolute value of x plus 1 plus y minus 5. Right? X plus y, positive 1, negative 5 gives us negative 4. So then the triangle inequality says that that absolute value is less than the separate absolute values summed. So absolute x plus 1 plus absolute y minus 5. And then what do we know? Well, we know x plus 1 is less than 0.03. So now we can do a strict less than. This piece is less than 0.03. And then the absolute y minus 5 is less than 0.08. And so if we add those together, we get 0.11. So that's an overestimate for the quantity x plus y minus 4. So that's interesting. What else here? Well, we want to estimate the quantity 3x plus 5 if we know that absolute value of x plus 1 is less than 2. So what we want to do is we want to try and relate these two quantities to each other, and then we're going to pull out the triangle inequality and put it to work. So 3x plus 5, if that was 3x plus 3, then this quantity would just be 3 times x plus 1. So what we're going to do is we're going to take that 3x plus 5, and we're going to break it up here to be absolute 3x plus 3, and then plus 2 on the end. And now by triangle inequality, this will be less than or equal to the sum of the two separate absolute values. So absolute 3x plus 3, and then plus absolute 2. So now, plus 3, not minus. So now we've got a common 3 that we can factor out of there. So this will be absolute value of 3 times the quantity x plus 1. And then plus absolute value of 2 is just 2. And then absolute value of the product is the product of the two absolute values, right? Absolute value of a times b is absolute a times absolute b. So I can break this product apart and say, well, that's absolute value of 3 times absolute value x plus 1, and then plus 2 on the end. And then what do we know? Well, we know x plus 1 is less than 2. So we know that this quantity is less than 2. So then that means that this whole expression is going to be less than 3 times 2 plus 2, right? Absolute value of 3 is 3. I took my absolute x plus 1, I replaced it with a larger estimate, 2, and then my plus 2 is on the end. So that's 3 times 2, 6, plus 2, 8. So we know that if x plus 1 is less than 2, then absolute 3x plus 5 has got to be less than 8. So you may not have seen a process like this before, and that's okay. We will have some more practice in the next chapter.